Hello everyone. So in past few days I've been trying to get this small project going where I've been playing with this robot called Cosmo and my favorite Raspberry Pi. And I wanted to see if there is a way to connect Cosmo and Raspberry Pi so I can send instructions from Raspberry Pi to Cosmo and it can execute it. Just to show you, this is the Cosmo robot. This is Raspberry Pi. And what I wanted to do was to connect these two together. And I thought that this may be a very hard thing to do. Probably it will take a lot of coding, a lot of um, searching online for resources. But it turned out to be a very simple thing. And once I figured it out, I wanted to share with you guys that how I did that. So let me first go over what all different things that will be needed for this. Number one, like I said, Cosmo will be needed. Um, this Cosmo I got as a Christmas gift. This is the collector's edition Cosmo. Um, Here's a box for it. If you can see, collector's edition. However, if you have the regular white Cosmo, then that will also work just fine. There is no difference between collector's edition and the white edition of the Cosmo, except for the dark color of this collector's edition Cosmo. And this will just the black and the white one, both of them will work just fine. Okay, we will need Raspberry Pi. So I use Raspberry Pi Model 3. Okay, so Raspberry Pi version 3 Model B. So this is the one that we'll be using. And I have also used something called SenseHat. So this is something that I found in my local micro center, and it had some different sensors on top of it, and I thought it's pretty cool. Let's just get it and play with it. And I never really found a good use of SenseHat. The sensors that it has on it is pressure sensors, um, accelerometer, temperature sensor, humidity sensor. Everything is built into it. It also has a small joystick where you can push it up or down, back, forth, keep holding onto it, and it catches the events. So it is pretty cool. It also has a small LED built into it. So you can turn on the LED, give it different colors. I mean, you can play around with it. The possibilities are endless. But once you buy something like that, most of the time you don't find a good use of it. And that's what was happening with my Raspberry Pi and the SenseHat, yeah. So in this project, I brought all these three things together. I used Python as the programming language, and yeah, I think that's about it. In terms of the things needed, you will need a Cosmo robot, a Raspberry Pi 3, a SenseHat, and you will need some basic coding skills in Python. Okay, so a little bit about Cosmo. So Cosmo is a robot that has four motors. Uh, it moves four motors to move its threads, and it has a head that can move up and down. Its wheel has encoders, so it knows how far it has moved, and also it can turn left and right. It has the ability to see, so it can see you, it can recognize you. But all of you who are thinking that, hey, probably FBI is collecting data right now through Cosmo, or it's another government conspiracy of collecting more information from us. So don't be worried. Cosmo connects locally to the Wi-Fi network it creates, and it never transmits the data out. And I have personally verified that. I have validated it. It never sends out any information, personal information out. So the only information that I saw going out of Cosmo was the version that the version checker, just to see how much what is the version of Cosmo and if it needs an update or not. Beyond that, all the information is stored by Cosmo itself. Even though it takes your picture for image recognition, it doesn't really store that image in Cosmo. Also, it converts it into numbers, and it then retakes your picture and then matches those two numbers. So it doesn't really save any picture per se. It just saves certain artificial intelligence data, the neural network training data, which in turn gets saved in Cosmo and not the actual picture, which is pretty cool. So you can be assured that if you give your Cosmo robot to your kid, I mean, his image is secure, it's staying within Cosmo and not going out. So all the cool AI features that Cosmo has is its own intelligence built into the robot. It is not in the cloud. It's not coming from anywhere else, and that's very cool. And then Cosmo also comes with a camera to take pictures, and it has a small LED screen on its face. So if you guys have seen this movie Wall-E, there was the Eva robot in there, Wall-E's girlfriend, I think, and it was like pretty cool the way its eyes moved up and down, and it could show all its expressions through its eyes, and that's exactly what Cosmo does. It is a very expressive robot, and its expressions basically come from its head moving up and down along with its eye movements. It's pretty cool. I mean, you really have to see it by yourself or watch some videos on YouTube to tell I mean the personality of Cosmo. And then there is an internal CPU that works in conjunction with a mobile app processor in Cosmo. So what we need to do in our setup is we need to have a cell phone. Okay, I missed it out from the original bill of materials, but you also need a cell phone which is in the USB debugging mode. So I happen to have this old HTC phone. I mean, I could use my primary cell phone also for this purpose, but I just happen to have an extra Android phone with me. All you need to do is to make sure that you go into settings, uh, tap the about phone, go down, go to the build number, and tap the build number 7-8 times, and then you enable the developer mode in your Android phone. Once the developer mode is enabled, you will see an option called developer options. Click on that and enable USB debugging. So I'm not sure how clear this is, probably not, but there it is. If you can see, the USB debugging has been enabled over here. You can see over here, and once the USB debugging is enabled, you can keep your phone aside, and we can jump right into what we need to do on the Raspberry Pi to set up your cell phone with Raspberry Pi. So let me step back. Why do we need a cell phone in this whole setup? So Cosmo basically interacts with its own local Wi-Fi network. Now one can argue that when Raspberry Pi also has a local has a Wi-Fi capabilities built in, especially the Pi 3 that does not need an external Wi-Fi adapter, why do we need a cell phone over here? The reason is that Cosmo comes with a Cosmo app, and that Cosmo app is available for Android, iOS platforms. Now, unfortunately, we do not have a Cosmo app for Linux platform yet, or I'm not even sure if they're gonna release any Cosmo app for Linux platform. So we need a a cell phone interface in between, and that cell phone will have the Cosmo app installed. We need to send instructions through USB debugging of the cell phone, of the Android device, and that USB debugging feature will take commands and it will send command right through the Cosmo app, and then Cosmo app will instruct Cosmo to do whatever. So we need to install Cosmo app, we need to set up Cosmo. All those instructions are available online or in the Cosmo booklet. I don't need to go into details in there, but you need to have a Cosmo already in Cosmo app installed and Cosmo setup, and you need to enable USB debugging on your Android phone where Cosmo is installed, and then we need to jump into the Raspberry Pi and see what kind of setups we need to do over there. Okay, so going into Raspberry Pi, um, let me okay, so I'm using a software called Vnc Viewer, and this Vnc Viewer basically lets you remote login into your VNC, into your Raspberry Pi. So basically, you have this VNC Viewer client over here, and in my case, my Raspberry Pi's IP address is 192.168.136. I had just given it some name over here, and this is all I need to provide right now to connect. And once I connect, I can remote log into Raspberry Pi. It also asks for your credentials the first time, and I have already provided my credentials, and I have saved into that autosave checkbox. So I do not need to give those credentials over and over again. But this is what we will get. My Raspberry Pi is already powered on, and I am able to log in. So just to double check, if we do ifconfig there we go. This is the IP address of my Raspberry Pi, and this is what we use to log in into the VNC client. Okay, so what do we need to do to set up the okay, perfect. So what do we need to do to set up the ADB, or the bridge that will talk, that is between Raspberry Pi and the Android device? What do we need to do to set up that bridge? So for that we need something called Android debug bridge, and the Android debug bridge is used to run the Cosmo SDK basically, because we are going to send the commands through the Android debug bridge from Raspberry Pi to Cosmo. So this is required for the Raspberry Pi to communicate with the Android mobile device over a USB cable, and it runs automatically when required. So now that we have enabled USB debugging on our phone, all we need to do is to connect the phone to Raspberry Pi. So this is the USB cable. This is the regular micro USB cable in my case, that is connected to Raspberry Pi, and I'm gonna try to install so let's do sudo apt get install Android tools ADB. Now you notice that I have already installed this, so it will probably not install it again for me. And we can just wait over here and see it's hitting the list of packages, and once it finds out that the latest version of ADB is already installed, it won't install it again. But in your case, if you have never installed Android Tools ADB, then in your case this will be installed. Okay, so now the second step would be to go to ADB devices and to see what devices are connected, and voila, we have our Android device connected over here. So we see some random number and the device next to it. That's the only device connected, so it's all good. So we have our ADB up and running and our Android device connected, so that's a good news. Now what we need to do is to install the Cosmo SDK. Now for us to install Cosmo SDK, I have already done this, and this is in this window over here. So the Cosmo SDK is pip3 install Cosmo. So now if you're using the latest version of Raspbian, then you will already have the Python 3 and pip3 installed by default. So all you need to do is to just do pip3 install Cosmo Camera, or you can do pip3 install Cosmo Camera with -- user sign, so it installs only in your user directory. I just went ahead and installed it in the system directory. So but I mean, if you would like to install it into the user directory for the isolation purposes, it's recommended to do it that way also. But either way, I mean, you will have the Cosmo installed, Cosmo SDK installed basically, and you will see screens like this with 4 progress bars, and then it will have it will be available for you basically. So now now one more thing you'll need to get is to see how some of the commands are working out on Cosmo. So there is a small file, and let me see if I can show you that. Hopefully if my Raspberry Pi responds. For some reason I'm facing some kind of latency issues. Okay, so there we go. So I have this Cosmo folder made over here locally. For some reason the VNC connection got lost. Okay, so there is something called Cosmo Sdk Examples that's available on Cosmo's website. You can download it from there. I'll also link it in the section, in the description section below. And in those examples, you will see there are a lot of things that you can do with Cosmo, especially in the tutorials section over here. I mean, you can play around with all these examples, and this is absolutely awesome that these guys have provided these examples over here. So we will look into this. But let's first set up our Raspberry Pi SenseHat, and we will see how the SenseHat works with Raspberry Pi. So okay, so you see that blurry, that's a filter that I'm using that may be causing things to look a little blurry, but it should be fine if I show you over here. Okay, so this is the Raspberry Pi, and you can see that there is a SenseHat already plugged in on top of it. I can show you a regular Raspberry Pi which looks like this. This is without the SenseHat, and on top of this Raspberry Pi, you just plug in the SenseHat on top of it, and that's it. So this is the Raspberry Pi with SenseHat on it. Okay, nothing fancy, it just goes on top of it. There are a couple of screws over here that you can just put on. One screw over here, one screw over here, actually two more over here, and these are plastic screws, so they do not interfere with the Wi-Fi antenna. I mean, if you are really thinking about that, these are plastic, they do not interfere with antenna, so it does not affect the signal quality of Raspberry Pi. Okay, so right now you will see a couple of things on my desk. Apart from Raspberry Pi and SenseHat, which are together, I have this cell phone connected to Raspberry Pi using this USB cable. So this cell phone is connected over here, uh, and this USB cable in any one of the USB ports. I have it powered with a power over here, power source over here. This is the RAV power external portable battery backup, whatever you want to call it. Uh, and this is just to power Raspberry Pi. Okay, so now I want to show you some cool little things about the SenseHat, and then we will go into some programming with the SenseHat, and then we will switch to finally programming with Cosmo. So you see that there is this up, down, left, right joystick over here, which actually does exactly same thing as the up, down, left, right keyboard keys. So and the center button actually is an enter key. So it actually emulates the same function that the up, down, left, right keyboard key does. Here is the LED matrix that I was talking about, and then there are some sensors. I can see that there is an accelerometer sensor over here. There is a humidity sensor, pressure sensor, a temperature sensor, at least the ones that I can look at right away. These are available. For those of you who would like some of the pins to be exposed, you may have noticed that all the pins are actually occupied over here. So I mean, there are no exposed pins that you can use for your project once you put SenseHat on top of it, which is actually not true. You can actually, there are some videos on YouTube, you can watch them. The SenseHat does not use all the pins over here, it only uses some few limited pins, so you do have access to other pins. You can potentially take some of these out. You will damage your SenseHat if you don't do it properly. Word of caution over there. But if you would like to do that, you can watch some of the videos. You can still access many of these Raspberry Pi pins for your other projects if you want to add SenseHat and still want to have the flexibility of having those pins available to you. Okay, so let me now switch to the VNC capture. Okay, so over here I can show you guys how we can do some of the coding with SenseHat. So I have written some of these sample applications, just so that, I mean, it's very simple application that I wanted to show you, where you can see how these few features that are available actually work. So I'll go over it. This is Python programming language. We need to import SenseHat. We need to import SenseHat from sense_hat, import time, import sleep from time, and import rand integer from random. And I will tell you why we are doing these things. So the reason why we are picking up rand integer is so that we can pick up a random number between 0 to 255, and I'm doing this just so that I can get a random color for a pixel. So I'll show you over here. This is a while loop where I am putting certain color on a certain pixel. So as you can see that this is 0 0, and this side it increases the y axis, and this side the x axis gets increased. You notice that I'm pointing my 0 0 towards the left hand side topmost corner, where you will see that the GPIO pins, uh, uh, the first GPIO pin is available, right? So that's where the 0 0 0 of x and y axis is. Notice that the x increases in the right direction and the y increases downwards. Okay, so sometimes people get confused in the pixels, because in our math class we read that the x increases on the right side but the y increases upwards, which is not the case in the case of SenseHat. The y increases downwards and the x still increases on the right side. Okay, so in this case I am trying to make an x symbol, and to make this x symbol I can either use a show letter command from the sense, but that will light up the whole letter in one single color. Excuse me. What I'm trying to do over here is to light up each individual pixel of this SenseHat LED matrix, each individual pixel of the X with a different random color, and that random color is being picked by this function over here. And this is just for fun. I don't think that I'm using it anywhere. It is just for fun, that if you guys want to do something cool, you can do all these cool things with the SenseHat. And then after that I am flipping it, and I can put a sleep of 0.5 seconds so you can see the flip. And let me do that, so it will be pretty cool to watch. And I will remove the counter to 10. Okay, and let me save that. So what this will do is it will create a flipping effect. It will show the arrow. This is actually an arrow. I apologize. This is not an X. This is actually an arrow. Okay. So this actually displays an arrow, and we'll see that once we put it on Raspberry Pi SenseHat. So if I run the script over here, you see that the arrow keeps on moving left and right. I'm not sure how clear this is with the glare, but let me run it again. Let me stop that and run it again. Okay, this is, so you can see that there is a kind of movement of an arrow, and that's because I'm just horizontally flipping and then clearing it, and then horizontally flipping it again after every 0.5 second. So it creates an arrow, horizontally flips it, waits for 5 seconds, horizontally flips it, waits for 5 seconds, and then it clears it. Okay, then you see that there is pressure, temperature, and humidity sensor capabilities in the same sense library, and I'm doing that, and I'm printing it so you can see the pressure, humidity, pressure, temperature, and humidity. This temperature is in degree Celsius, so if needed you will need to convert it down to degree Fahrenheit if that's what you need. And then excuse me, and then there is this particular very useful method, direction any, which captures the joystick movements. So let me show you what I'm talking about. So I'm going to close this, run the script again. Okay, and it is doing that arrow dance over there. And once that arrow dance is done, I'm gonna move the joystick. Let me move this a little bit up so you can see the whole screen. Okay, and I will move the joystick down, and you see that it captured the down pressed and down released. If I press the joystick right, it captured right pressed and right released. If I do left, it captured the same thing, and up captured the same thing. Let me press the middle button and it captured the middle. So you can capture left, right, up and down and the middle, both pressed and released events over here. And once you capture these, you can assign actually a function to it. So in this case, I have assigned a do thing function to the direction any. Okay, and do thing function then takes the input parameter as event, and this event you can check the direction of it. You can print the direction and action. So this is what I'm printing right now, but you can also check, you can do some logic over here with the if condition. You can check if it was held or not. So if you keep on pressing up and holding this joystick, it goes into the held state, and when it goes into the held state, it says it is held, and then I am actually, okay, over here I'll do it again. If I do down, it shows you it is held, then released, again down, held and released, left, right, right. And I have also coded over here that if the event action is held, then draw a letter X excuse me, with the random color picked up. And once it is released, just plain clear the sense. So it clears the LED matrix over here. So that's pretty cool. It's a very simple thing to do. The whole reason why I wanted to show this is because I wanted to have the direction any method, the event concept, and the conditions that we can use over here based on certain events that we generate by pressing the joystick. Okay, so now let's move on to Cosmo part of the equation. So in Cosmo, we already saw that there are some tutorials where there are some basics, and there is a hello world part of the Cosmo. I will double check and make sure that my phone is on, because before interacting with Cosmo, we need to make sure that the Cosmo app is up and running. So let me click on Cosmo app. Cosmo app will ask me to connect with Cosmo. Okay, so what I'm trying to do is just increase the brightness a little bit so you guys can see it better. Okay, hopefully this is clearer. I need to connect. It is searching for Cosmo right now, and let me try to turn on Cosmo over here. So it wants me to connect to Cosmo's Wi-Fi. So what I'll do is I will go over here, search Cosmos Wi-Fi, if I can find it. Let's see. Cosmo, where are you? There you are. Okay, so I connected to Cosmo's Wi-Fi, and Cosmo is sitting right here, just next to all these wires, right there. Okay. And there we go. So Cosmo is connected, and now there is a local Wi-Fi network between Cosmo and my Android phone over here. Okay, so now that the Cosmo is connected, what we want to do is we will switch back to, one moment please, we will switch back to the VNC, and I will show you the very first program that we can make from Cosmo. Okay, so let me put the phone away, and let me switch over to the VNC capture. There we go. Okay, so now in the tutorials page, we had, in the tutorials folder, I mean the basics, we had this hello world kind of sample Python script, and in this you will see that we need to import the Cosmo library, and then I also imported time just in case if you need to put some weight over here, but in the basic Cosmo, what do you call it, the Python script, this time library wasn't there. I just modified it a little bit. I can also remove it right now from here, just so that it is consistent with what you guys will see. And then if you type anything over here, right, so this program actually comes with hello world written over here. Okay, and if you run this particular, let me make sure that I am not running this, so I'll stop this, and then I will run this and see if Cosmo, our robot, is able to say hello world. So yeah, it has a robotic voice, very cute voice I would say, but it does say hello world very cutely. Let's change a few things over here, and let's see what else can we make it say. This is awesome. This is awesome. Awesome. And just because it is fun, I'm gonna make it say something else, something longer, to see if it does that. Please now. Let's see how it responds to question marks. Can you connect me with Raspberry Pi, please, now? So it does actually respond to question marks, because his statement did convert to a question, but I don't think it was able to respond to multiple question marks. One another thing you can do is so Cosmo basically does not say any swear words. So because usually kids play with this robot, and it just blocks out the swear words if you want to make him say that. But if you are in the SDK mode, you can make him say anything you want. So if you want to make Cosmo swear at someone, then definitely put it into the SDK mode, and then you can make it do that. I'm not gonna show that over here, Just I wanted to let you guys know about that. In the SDK mode, Cosmo will say anything you want it to say, but just from the app there is an option in the app where you can make Cosmo talk. um, it doesn't it doesn't say it actually says no. It shakes its head and says no. It will not say any bad word basically. So yeah, so a lot about a simple hello world Cosmo program. Let's see something else. Let's see drive and turn program over here. Okay, so in this drive and turn program, you will see that they have imported Cosmo, and then from Cosmo util they have imported degrees, distance in millimeter, and speed in millimeters per second. So that's how Cosmo calculates its distances and speeds. So you need to define a function over here, and in that function you need to use the robot variable, and then there is a drive straight uh, method where you need to pass the distance in millimeter, how much distance you want the Cosmo to travel, and Cosmo will travel the distance accordingly. So let's say I mean 150. I don't have enough space over here. 150 millimeters. Let me see. Let me see. I'm gonna make some space. I will put Cosmo a little bit behind. I'll make it walk like 50 millimeters and at a speed of 50 millimeters per second. So it will cover this distance in 1 second, and then it will turn around. It will turn 90 degrees to the right. No, to the left, sorry. It turns 90 degrees to the left, and then um, yep, and that's what's gonna happen. So let's see that. So it will go forward and then it will turn 90 degrees to the left. Let's do that. There we go. And if I change it from 50 to, let's say, 100, then let me keep it back over here and try to move Cosmo again. It will move 100 and then turns towards the left. Awesome. So now we know how we can make Cosmo move. With what speed, how much distance, and how to also make it turn. What we want to do now is to integrate the Raspberry Pi, SenseHat, and the Cosmos Motion. So in order for us to do that, I have already created a sample program over here. Let's see, it is, here it is. So I'm gonna open it in my IDE. There we go. So it looks a little bit of lines, but actually it is very simple and straightforward, guys. So let me explain it step by step. So what I have done is imported SenseHat, time, rand int, because I was initially trying to do some things which I didn't do later on. So we are not gonna need time and rand int for this particular project. So let's delete them, and we are gonna import Cosmo util to get the degrees, distance, and speed basically. So what we are doing is we are importing the sense library, and we are importing the Cosmo library basically to get things combined. Okay, we are gonna define 4 different methods over here, 4 different functions. There is a function called up, function called down, function called left, and function called write. Okay, the Cosmo program up has the movement of going forward 50 millimeters at a speed of 50 millimeters per second, and Cosmo program down does the reverse of that, so it goes backwards 50 millimeters. The left just turns it to the left, and right turns it to the right. Now what we need to do is we need to trigger these events based on the SenseHat. So SenseHat has a joystick that we looked at earlier, and I want to trigger all these left, right, up and down events based on the SenseHat's joystick. So what we are going to do is define a doThing method over here, which will take an event, and this is how we are going to do that. So SenseHat stick direction any equals doThing, and doThing actually will take this event, and on the event action pressed, it is going to do certain activities. So why I chose the event action pressed is because if you recall, there were 3 event actions: pressed, released, held. So we don't want to do anything when it is released, we don't want to do anything when it is held, but we only want to do something when it is pressed for the first time. If you keep on holding it, in that case Cosmo will not respond to it. You have to press it at multiple times for it to work. The reason why I built that thing is because Cosmo does come with a sensor, a cliff sensor. So if Cosmo is going to fall down from the edge of your table while it is in its regular operational mode, then Cosmo will avoid that fall. But if Cosmo, if you are using Cosmo with the SDK features, you take control over that. So just to avoid him falling down because somebody kept pressing the held, I tried to not include the held over here, but only the pressed over here. Okay, so I'm attaching the event direction. If the event direction is left, I'm attaching the Cosmo run program left, which is this particular one over here. If it is right, if the event direction is right, then I'm attaching the right program. Up, then attaching the up, and down, then I'm attaching the down program. So now if we want to see how this actually works, I'm gonna run the script, and I will be lifting up the SenseHat over here. Not sure if you can see it, maybe not. Maybe I can just keep it. Oh yeah, this is better. Okay, so I can press the up key, and then you see that I held the up key for a little while, but Cosmo did not move forward. It would have hit the thing in front of it if the movement was also associated with the held. And the reason why I'm talking multiple times about this particular aspect is because I did attach it with just the direction, and then I did not realize why Cosmo keeps on moving and moving till I got to know that there are 3 different event actions: pressed, released, and held. And the best way to do it is to keep it on the pressed action. So now if I move it backwards, it moves backwards. I press the left, it turns left, and I press the right, it turns right. Okay, go forward, go forward again, and to collide, go backward, and backward. There we go. So we have like a fully controllable Cosmo over here with the joystick. Let me maximize the camera and show you how it looks like um, over here. Okay, so again, forward, backward, backward, left, right, right. Okay, I can now try to make him go forward, try to make him left. Okay, now make him go closer to the camera. Perfect. So as you can see, there was not a lot of coding required over here, and there was also not a lot of tools needed to do that. If you already have a Cosmo, Raspberry Pi, SenseHat, I know that there are a lot of things needed over here. I get that. But definitely, I mean, I had these things available with me. They were laying around. I never got bored of playing with Cosmo, but integrating Cosmo with Raspberry Pi and the SenseHat, it was really a fun project, and it did not take much long to do. I really enjoyed, I mean, the satisfaction of getting it done was really awesome. Now, what other things that I want to do in future is to um, make Cosmos say the temperature, and he can also tell me uh, if the temperature is beyond certain threshold limit. It can scream, it can do some crazy things, it can walk around the house if the temperature or the pressure or the humidity is not good, or if, I mean, it now also has the sensing capabilities of the atmosphere apart from the sensors that Cosmo already has in it. So this makes it pretty cool, that by enabling the SDK, the developers actually did a very cool thing, and it opened so much worlds of possibilities for tinkerers like me who want to actually make use of their tools that are sometimes laying in the closet doing nothing, like my SenseHat and my Raspberry Pi. Okay, so I believe this is all I wanted to talk about. I really enjoyed making this project. I really enjoyed making this video. If you find this video interesting, give it a thumbs up, like it, subscribe to the channel. If you think that you will be interested in making this project, then please leave a comment, tell me how it goes. If you face any issues, difficulties, let me know. I will try to help you out. I will post all these code snippets into my GitHub account, and I will link that down below. And that's it. Thank you very much for watching this video. And please do let me know what you think about it.